Hey everyone, this is the Using the Unit Circle video series, using the unit circle. I will call this part 2. And I wanted to just recap what we did in part 1. So in part 1, we derived the formulas. Let me go here. We drew a triangle in the unit circle. We said that the angle is here. And we knew that the radius of the unit circle is 1. This is the x value, this is the y value. I'm not going to narrate this in a really detailed way because that was what the first video was. And then we had the sine, the cosine, and the tangent. And then what is the reciprocal of sine? Cosecant. The reciprocal of cosine, secant, and the reciprocal of tangent, cotangent. And I like to line those up. The sine of theta is opposite over hypotenuse, which is the y value. The cosine of theta is adjacent over hypotenuse, which is x over 1, or just x. Same with the sine, opposite over hypotenuse, y over 1, which is just y. And then the tangent is opposite over adjacent, so y over x. And then lined up across from those trig functions are the reciprocals. So the reciprocal of cosecant, I don't really like to write this 1 over y. I'll show you when we do the problem how we're going to do this. The reciprocal of cosine is secant, so that's going to be 1 over x. And then the reciprocal of tangent is cotangent, so that's going to be x over y. And those were the formulas. So what I want to do is show you just one example. We're going to use 315 degrees, a pretty straightforward one, and we'll see more complicated examples as we go forward. But in this video, I just want to give you one example of this. So let's do the sine and the cosine and the tangent. And then the reciprocals would be cosecant, secant, and cotangent. Oh, I don't want to write theta. I'm going to write 315 degrees. So we're going to look at 315 degrees. And using the unit circle, we're going to give the values of all of these trig functions. Okay, and then the last thing from the video, I had showed you that this little trick, how I remember cosine and sine, it's an alphabetical order. So cosine comes before sine in the alphabet, and x comes before y. So if we go to 315, the first thing you're going to do is just locate where you are on the unit circle. Which we would be here at 315 degrees. And you can see the coordinates there are root 2 over 2 and negative root 2 over 2. Okay, so based on this triangle that we drew, the hypotenuse is 1 for any triangle that you draw in the unit circle. The sine is always going to be the y value. And so what you would do is you're trying to figure out the sine of 315, go to 315 degrees, and the sine is the y value, and that is negative root 2 over 2. And because we have these functions lined up with their reciprocal, that means the cosecant is going to be the reciprocal, or 2 over negative root 2. The cosine, you can see it here, is the x value. I also just use this trick that the cosine is always going to be the x value. So the cosine is the x value, which is root 2 over 2. And again, the reciprocal is secant, and so that's going to be 2 over root 2. All of this is based on the 30, 60, 90, 45, 45, 90 triangles. It's all based on this triangle as well, that the hypotenuse is 1. You don't have to go through that much thought. All of that work is just to show you how this was derived and where those numbers come from. But then when you are just using the unit circle, then you are just grabbing the x value for the cosine, the y value for the sine, etc. The last one, tangent, is a little bit more interesting because tangent, remember, is y over x. That's right here. So you would do the y value divided by the x value. And here's the easiest way. Those are almost equal to each other because it's root 2 over 2 and root 2 over 2. So they would cancel, and it's just going to leave you with negative 1. The other thing you know how to do, if you didn't happen to recognize that, is that division bar. that if you are dividing, that is the same thing as multiplying by the reciprocal. And the 2's cancel and the root 2's cancel, and you're just left with that negative sign. And so that's -1. The cotangent is the reciprocal, so you just think about the reciprocal of -1. And I'm going to erase this just to make a little bit of space. -1 is the same as -1 over 1. The reciprocal of that, flip it over, and that's actually still equal to -1 because 1 divided by -1 is -1. And so that would be all 6 trig functions at 315 degrees. So like I said, this will get a little bit more complicated, a little bit more interesting, but that's where I want to stop with my examples for this video. And then if I could show you one more, or actually have you try one. So 135 degrees. If you want to pause right now and try to do all 6 trig functions at 135, you can go ahead and do that. So we'll do sine, cosine, and tangent. If you want me to walk you through the steps, I'll go ahead and do that, but you can feel free to pause and try this on your own. What are the reciprocals? So what's the reciprocal of sine? Cosecant. What's the reciprocal of cosine? Secant. And what's the reciprocal of tangent? Cotangent. Okay, go ahead and find 135 on the unit circle. We're here, so it's going to be pretty similar to the one that we did. And the sine is which one of those coordinates, the x or the y. So the sine will be the y value, root 2 over 2, and you can automatically fill in the reciprocal. The cosecant is 2 over root 2. Which one is the cosine? That would be the x value, negative root 2 over 2, and the secant is the reciprocal, so 2 over negative root 2, just flip it over. And then tangent, do you remember the formula for tangent? It's y over x is tangent. And so you're doing the y value divided by the x value. So the quick way, if you see that those numbers are really similar, they're going to divide and cancel and leave you with -1. If you do the y value divided by the x value, you know that division is the same as multiplying by the reciprocal. You see this cancellation, and the only thing left is -1. And then cotangent is the reciprocal, so the reciprocal of -1 is also -1. I won't say those steps again because we just did that in the previous example. So that is one example, actually two now, of how to use the unit circle to get these values. And then we will see some more varying examples in the videos that are to come. Great job.